Assalamualaikum warahmatullahi wabarakatuh. My name is Haryo Kunto Wibisono. I'm from Group 3. What is DFS? Depth first search is an algorithm for searching a graph or tree data structure. The algorithm this start at the root top node of a tree and goes as far as it can down a given branch or path, then backtrack until it finds an unexplored path and then explores it. The algorithm does this until the entire graph has been explored.
Okay, the first time is I will explain about the DFS work step. And in the DFS work step is the set, the content, the element is three knot, and is the sequence of the algorithm. In first, put the root knot in the pile with the push, and second is the pick and save the contents of the element from the top of the heap. 3. Remove the top stack contents with the pop procedure. 4. Check if the 3 knots keep early head knot. 5. If the true, push all knots raised into stack. 6. If the empty pile stops, but if it doesn't go back to step 2. Next is the deep first search application about the deep first search. Deep first search is used in topological searching, solving the problems, schedule problems, cycle detection in graph, and solving the puzzle with the only one solution, such as maze or a Sudoku puzzle. Other application involve analyzing networks. For example, testing if a graph is a bipartite. The first search is the often used subroutine in the network for algorithm, such as the Ford-Fulkerson algorithm. DFS is the also used in the subroutine matching algorithm in the graph theory, such as the Hopcroft algorithm. The first search are used in mapping routes, schedule, and finding spanning trees. Okay. Next is the illustration about DFS or deep first search. In here, you will see the picture is the illustration about DFS, and is the structure tree. And DFS is where the search for the deepest first. The meaning is for the example is in the picture you will see the number 1, 2, 3, and 4. And in here you must to have the until the number of the deepest. After that, you can only find the others number. And here the picture 1, 2, 3, 4. And after that, you will go to next the number is the 5, and next the 6, 7, 8, 9, 10, 11, and 12.
My name is Yogret Valis Matthias Maro, and here I want to explain about code and then the method to find the result. So this is the public. We use the public hash for this code, and then for the method, and then the v is number of vertical or the vertex, and then we use array of list for agency list representation. And after that we use or we make graph constructor with the linked list, and then as you can see the method is v, as I said before, v V is the number of vertices. Adjust for the linked list.
This is a part order to repeat agents point for the device. There are a void util function for declaration v and visit function, and v use type data integer and visit type data is boolean, and mark the current node as visit and print it. If visit function v equals true, so system out print out is the v value, and there recur for all the vertices adjacent to this vertex. Iterator integer I equals agents v point list iterator function, while I point has next function in n equals I point next function. If visit n, device util n and visit.
Okay, next is the shortcut in the, for example, deep first search, and here you can see the picture and the shortcut. First is the with dvs integer v. Is the meaning is the function to the dvs traversal. It use a recursive dvs util. And next shortcut is the boolean visited equal new boolean. Is the meaning will mark all the vertices as not visited, set as the false by default in Java. The next shortcut is the dvs util v and visited. Is the meaning is to call the recursive helper function to print the dvs traversal. And here in the next shortcut you can see the value or the output or the result, and this like the almost same the illustration that I explained before. And if you enter the number from the earlier to the deepest, the next step is the same like the before step.
And the last, I will explain about advantage of deep first search and disadvantage of deep first search. And the first is the advantage. There are consume less memory. It's very important in nowadays for the technology. And then the second, finds the larger distance element from source for text in less time. And then the third, memory requirement is linear with WRT nodes. The fourth, less time and space complexity rather than DVS or deep first search. And then the last advantage is solution can be found out by without much more search. And then the disadvantage of deep first search. And that's all from us. We are very sorry if we have some mistake.